All right. Typical assembly when we come in there, from the right hand side is our gas feed coming towards our furnace. Every appliance should have its own isolation valve. That isolation valve should be within reach. That is, and we have to kind of do a little bit of imagination, because when it's all together and working and we don't need it, we're not going to kind of figure things out. So we have to look at the order of things as well. That the whole purpose of that isolation valve is so I could turn the gas off and then disconnect the furnace for whatever reason. And if I have to put a new one, I could put a new one in there. All right. So gas cock, union coupling, drip leg, and then come into the unit. Now this one here, the furnace is off on the left-hand side, and the gas is actually coming from above. So using our pointer again, this is where my gas is coming in. We go to our drip leg, and then we go to our isolation valve, and then I go over to my furnace. All right. But if you think about this, if I have to disconnect this, so I turn the isolation valve off, and then I go ahead and disconnect this, well, I got no way now to turn the gas off, so I'm just going to be leaking. So this was, we found this on one of our field events. And again, it's real easy to walk by some of these things because everything's working normal. And it just doesn't come into the brain to start thinking about the order of stuff. So you kind of have to pull things out there. We want to make sure that our isolation valve comes before the drip leg, before the universal fitting on there. Flexible gas appliances. I can't tell you how many times I see people using these things and using them wrong. All right. This slide might not have all the rules that are on there. I would like to make sure that we do understand most of the rules, if not all of them, when it comes to these gas appliances. Number one is the length. All right. And I don't think they sell gas connectors longer than 6 feet anyway. I know you could buy CSST stuff, but not gas connectors longer than 6 feet. We can't daisy chain them. All right, so I can't take one 6-footer, put a fitting in between them, and another 6-footer to reach my appliances. Maximum length 6 feet. Even if I get two 2-footers, and that's only 4 feet, which is still under my 6-foot mark, I can't do that either. So we can't daisy chain these things together. They can only be used once. So once an appliance has been removed or disconnected, the entire gas connector is supposed to be thrown away and a new one installed for each one. They cannot travel through a structure or a wall of any type. So in this diagram, we're showing where the gas connector comes in from the room to the right, or the cabinet to the right, goes through the wall, and then behind the stove in there. Even if it was like a furnace, you can't even run the flexible gas connector into the furnace and connect it there. You have to have a steel pipe coming out of it, and then you have to connect the gas connector to that one. Shutoff valve should be in the same room wherever the appliance is, and even when we're dealing with cabinets, the shutoff valve should be in the same cabinet wherever the appliance is. All right. It can't be concealed. No, it's a little misleading. It could be concealed, such as behind the stove where you can't see it. But what we're saying is you shouldn't have to build a little chase, like a soffit box or something, and run the gas pipe through that. It shouldn't be fished behind any drywall. Everything needs to be out in the open where we can see it. Again, used one time, no longer than 6 feet. Don't daisy chain them. Cannot go through a structure and cannot go through an appliance wall. Just a simple flexible gas connector. We have the shutoff valve in the basement. They ran it to a stove upstairs. Instead of running black pipe coming up there and putting the shutoff valve upstairs, we ended up doing it downstairs. Obviously, it's wrong. Old brass ones like these, they've all been recalled, and I can't tell you the last time I've ever seen one. It's going to have to be on a pretty old house. Most of the time, the appliances failed, and people have had to put a new one in there. It is what it is. In the Chicago area, here it's very common that appliances such as water heaters and furnaces are all black pipe, straight into it. We don't use appliance connectors, all right? However, most codes, especially in the suburbs, do allow it, all right? And it's not necessarily a bad thing. It can't go through a structure, but it can connect a water heater or a furnace. So that doesn't mean it's necessarily a bad thing. However, I would still be a little bit suspicious. It's not a common practice that we do this. Coated stainless steel or CSST. These are flexible gas lines. These are designed to go through. These are designed to go through structures, per se, and they usually will have a manifold right where it comes into right where the gas enters the building, and we're going to have one of these lines going to each one of the different appliances, and there'll be a separate shutoff for each one of those lines. Part of the problems, and I've actually been on a couple of fires where this has happened. A couple of problems with CSST is if you don't ground or bond these things properly and the house ends up getting struck by lightning, then we start getting sparks. They don't do a good job because they're very thin, they don't do a good job at dispersing the electricity that comes from the lightning strike. So if they're close to a plumbing pipe or a grounded appliance or anything like that, then there ends up being a spark between the pipe and the appliance, and that spark, we're talking a lightning strike, so it has a tremendous amount of power. What's been happening was it creates a hole in that pipe about the size of a pencil, all right? But a hole the size of a pencil at 1/4 of 1 psi is pretty powerful. And then all of a sudden it starts spewing a whole bunch of gas into the building, looking for an ignition source, whether spark from light switches, furnaces, water heaters, dryers running, whatever it may be, even a hot light bulb for a reason. And it's been the culprit for burning houses down. And the two that we invested pipes, and the house probably got struck by lightning. So we're supposed to have these things bonded, and typically on both ends of them, because they're not strong enough to conduct the electricity. So we need to give that electricity a pathway someplace else to get to the water pipes, and then get it out of the house. All right, CSST. The yellow stuff is the one that needs to be bonded. I believe they came out with the gray one now, and that does not require bonding, but I would have to do a little bit more research on that one. So I do want you to look up the color coding for the yellow CSST and the bonding requirements on that as compared to the gray CSST. And this is what I was talking about, the manifold. This is what we commonly see. So gas comes in. Looks like we got 5 different gas appliances. We run one line for each one of them. Looks like they wrote on there exactly what it is. Typical manifold with a shutoff on each one of them. Looks pretty good, but it's not bonded, at least not at this end. Teflon tape on gas pipe is basically a no-no. I don't have any history or knowledge where these things have actually failed putting Teflon tape on there, so I can't speak to or against it at all. But rules are rules. We don't make these type of rules unless something did happen. So usually it's going to end up being pipe dope is what we'll see on there. Now, there is a Teflon tape that is made for gas pipes. It's yellow in color, and that's supposed to be its identifying mark. I have seen that, and it fades to like a creamy white after about 10-15 years. And this white Teflon tape kind of fades to a creamy yellow after about 10 or 15 years. So it's not always going to be brand new white or brand new yellow that you come in there. Sometimes we're going to be a little bit confused when it comes to it. But yellow Teflon tape is okay. White Teflon tape, no way. And preferred, and so there's no mixture, is going to be pipe dope that comes in there. So if we look to the right where the gas meter is, and again we'll come over here, and this fitting down here as well, even down below, oops, I can't get down there, but even the one below the dot, those are all the yellow Teflon tapes. And then what we have up at the universal, it looks like this one is yellow as well. And then I'm not sure if somebody just replaced this pipe in here. Maybe they needed to make it longer or shorter for whatever reason. And now I'm seeing the white Teflon tape in here. Again, I'm a big fan of using gas detectors, and we would take our little Klein tool and check each and every joint when it comes in there to see if it's leaking. Because it's not allowed, I just don't want to take ownership of things. So these are things that I do document if I see the white tape on there. But I can't, I don't know, maybe I'm wrong, but I just can't in my right mind tell someone, undo this, put the pipe dope in, or the yellow tape in there, because it's the raw material that was used. Unless I have some sort of intimate knowledge that this has created problems. And I just don't have that. I just don't believe that it happens. But I'm still going to tell my person that it's not, or my client, that it's not allowed. And, if you want to be safe, then go ahead and change it out. That another good reason is when you go to sell this house, if anybody's on their game, they'll probably be calling it out then too. And somebody's going to maybe make an issue out of it at that point. We all have different opinions when it comes to stuff. And whatever our clients hear and how serious things are, that's kind of up to them. So, galvanized pipe. It's not the best practice. Everything should be black iron. All the threading and the sizes are the same when we're dealing with galvanized pipes. And when I first started in this business back in the 90s, it was somebody, I was told that, the galvanized pipe is going to leak and, it's going to corrode with the gas inside of it and the fittings are going to go bad and you're going to burn your house down. And, I've been in the fireman business for almost 40 years and I never run into a house that caught on fire or heard of another investigation that showed that it was galvanized plumbing that came in there. All right. And for me, it was just something I always called out. And I had this plumber one time, and he just lit me up like there was no tomorrow. And it was really old guy. He was real short, maybe about 4 feet. And I stand about 6 feet tall, so, I was over him quite a bit. And I don't know if you could picture those old Mickey Rooney type guys with a cigar in their mouth. It's not lit, but it's been there for like 10 years or so. And that's what this guy, and he starts pointing me and poking me in the chest like he wants to start a fight with me. And again, he was like in his 70s, and at this time, I think I was in my 30s, maybe early 40s. And he's pointing up at me and using a few colorful metaphors. I said, never once have I ever seen where a gas pipe was leaking from this. And I started thinking, I'm like, wow, the guy's right. So I don't call this out anymore. I'll identify it, but really that's about it. Now, I do know there's a lot of suburbs in our area that do city inspections when there's real estate transfers. And North Lake actually came to mind, and I don't even know if they still do this or not, but North Lake has it in their transfer protocols that all gas pipes have to be black pipe. All right. Now, I interpret that as being black iron as the material, but their interpretation of it is color coding. So they're okay if it's black iron. If they do see galvanized pipe like this, then somebody has to paint it black, and that's their solution to that. So again, I'm going to stick to my opinion, and that's all I'm doing is sharing that, is that galvanized pipe really isn't that big of a deal when I see it, but I'm still going to go ahead and identify it. Drip legs, we talked a little bit about it already. Anytime I have a drop, we want to give away for the sediment. If there's any oils or moistures or anything that's in there, we want to go ahead and give that a place to collect so it doesn't come into the gas valve and damage our gas valve. This water heater, I don't know if you could see it down there at the bottom, right above the cursor here. There's actually scorching coming out of there. So that's a pretty good indicator that either we're depressurized in the area or we have a very bad gas-air mixture and the fuel is spilling out of the opening and igniting and causing that scorching to be there. But we'll talk about scorching in a little bit. Propanes, for those of you in the rural areas, I'm not going to go too crazy on this. I do want you to know propane is far more flammable than natural gas is. All right. And I do believe propane is a mixture. It's not just one gas. I think it's butane and propane. There's a LPG, liquefied petroleum gas, and it's some sort of mixture between the different fuels that they go ahead and create. Now, typically one tank, when they go ahead and fill it up, they're supposed to be big enough to get the house through one heating season on normal use. Sometimes it works, sometimes it doesn't. So usually in the beginning of the heating season is when these things get filled up. They do have to be kept away from the home. And on the next slide I'll go ahead and show that distance. But going back to the flammability thing, if you do convert from propane to a natural gas, in other words, if I take a propane device and I hook it up to natural gas, like let's just say a propane grill, and I decide I want to run a gas line out there to this one so I don't have to buy those tanks again, and I hook it up, I'm going to get a real bad flame coming out of there. Very little fuel. It's going to be very limited on what comes out of there. I'm not going to get a lot of heat coming out of it. It's not going to be able to cook anything. I have to change the regulator out of it so that I could allow more fuel to pass through of it. And even the orifices, all right? So where the gas shoots out before it pulls in the oxygen and mixes with it, the propane orifices, because they're more flammable, they're under a higher pressure, those are going to be smaller. They're going to limit the amount of fuel that's going to shoot out of there. The gas orifices are going to be bigger so that more fuel can come out of there. All right. I have heard of that as being a test question, but if somebody says they put their grill on there on a natural gas and now they don't get any heat, that's the reason. The orifices are too small. Same thing if I bought a furnace that's designed for natural gas and I put it on a propane heater, now I'm going to have too big of a flame because those orifices are going to be bigger and we're going to be putting a larger pressure in there. All right. All right, just our distances. Small tanks, they need to be 5 feet away from the house. Medium tanks are going to be 10 feet away, and that big tank that I showed you, which is pretty much a 2,000-gallon tank, those have to be at least 25 feet away from the house. So usually they're going to run the lines below grade and then come back up into the house. And then you could also see our distance to, ignition sources and property lines. Now, our ignition sources are going to be outlets, air conditioning compressor units. If you have an outside distribution panel, that would be considered an ignition source as well. So, appliance cannot be located in a basement or pit. It has to be vented to the exterior. What else we have? Propane, like natural gas, is odorless and colorless. So you're going to need a natural gas detector to go ahead and sense that. It does require 2.5 times the amount of combustion air as compared to natural gas. Because it's more flammable, because it creates a fire, the more fuel we have, and the stronger or the more rich the fuel is, the more oxygen I have to put in there. That's its rationale behind it. All right. Oil feeds. And again, we don't have too many of these things, so I'm not going to hit these really hard. We're just going to give the quick chats and stuff we're looking for. So first thing is identifying them. Typically, we're going to have 2 pipes. One's going to be our fill and one's going to be our vent. Once I put liquid inside of a tank, I have to let the air that's in the tank get out of it. And in order for the liquid to come out of the tank, I have to let more air come back into it. All right. These tanks are not under any pressure, so they're just gravity fed, and that's it. In our area, if we have an unused, buried storage tank, it has to be removed. It's not cheap, and especially if it's leaked in the past, then it gets pretty expensive. So the guys that go ahead and remove these tanks, they're going to dig around the area, remove all the soil, especially anything that could have been polluted with the oil. they're going to make sure all that soil is removed as well. Then they have to come back and put additional stuff back in there. So typically in the Chicagoland area, I think they were quoting somewhere around 10, 20,000. And that was maybe 5-6 years ago, so I'm sure the price has gone up since then. It's not a cheap thing to do. And that's only if it's buried in the earth. It doesn't mean that it's below grade. So if you go into a basement or a crawl space and you find an oil tank there, that's going to be up to your client. There's nothing that says it has to be removed. Sometimes it's actually more dangerous to remove it than anything else. Just because the only way to get it out of those crawl spaces is to cut it up into smaller pieces. And when you do that, you've got a chance of making sparks. And if there's any oil fumes in there, you're taking a good chance of, exploding something at that point in time. So if you do see any sort of oil pipes coming outside, the fill pipe will be bigger than the vent pipe coming out of there. It's going to be a good clue that we have oil or had an oil storage tank on site. All right. This was a house that actually had it inside the crawl space, and you can see the pipe coming up with the cap on it. That's our fill pipe, and then the one going down is our vent pipe. And we did have an oil tank inside there. If the oil is being used, it does need to be kept away from any ignition sources. So again, outlets, furnace, water heaters, anything that's going to go ahead and create a fire. Minimum distance is 10 feet. A lot of times we'll see in our area, there'll actually be a wall that gets built because we know that there's a spill, it's going to be a liquid, it'll be on the ground. And if it's air, it's heavier than air, so it's going to stay down low as well. And we don't want to let that or make its way over to where the ignition source is. So 5 feet if there's a wall, 10 feet if there isn't. When we send our fuels into the flue, we have to dilute that air. So I used the term of combustion air before. Combustion air is the air that I need to mix with the fuel to make the fire. As I make the fire, I'm going to get to certain temperatures. Typically, oil is going to be closer to the 600 to 900 degree mark. And when that happens, we need to put in some cool dilution air with it. In oil systems, we're going to be using something called a barometric damper. Now, that little weight on the bottom of this thing right here, that is basically designed to keep it closed. And as the hot air goes up and through that pipe, the hotter it gets, the faster it moves. The faster air moves, the pressure actually drops. So when we lower the pressure, we create what's called a Venturi effect. And then this door gently opens and starts letting in 70 degree air or dilution air. And that mixes with the hot air that's going up and out, so that brings that temperature down. Now this thing's designed where it's going to find that happy place. So as it slows the venting down, it's going to get to a certain opening. Too fast, it opens more. Too slow, it closes until finally it gets at a happy point. That opening, that damper, should be very easy to move. All right, it should. If it's rusted at all, and I wouldn't touch it with my hand on there, I would just give it a tap with a screwdriver or something and make sure that it just swings freely and ends up coming back closed when it's not in use. But if it's rusted, stuck in the open position, stuck in the closed position, obviously that's a problem and it needs to be corrected.